All right, let me show you how I work with given when thens. So let's say we are modeling something like bank account management. The pink sticky note is something like a context, so I can name my model on the board. So the first thing that happens is, let's say we open an account. Let's say we define a few fields that we know of. Account owner, for example, and the account number. And we could provide something like the initial balance maybe, which could be a decimal. Now, what happens if an account is open, and how does this happen is the first question. Well, an account is opened by a simple command which says open account. And we provide a simple screen. So we could draw a screen, but for now, we just keep it simple and say there is something like a screen where the user can click. Now, what I can do is I just select all these elements and I link them and I create a slice for them. That's beautiful. Now what you see here is the information completeness check, which checks at all times that our system is information complete, which means that we provide all the information. So currently our account opened event expects some information, but we do not tell the system where this information is coming from. So what we need to do is we need to tell them. By the way, look at this indicator, which tells you this is wrong. This is perfectly fine for colorblind people, right? Now let's just copy over the fields here to the command, which just moves the red arrow one level to the top. And let's say we provide this information directly from the screen. Amazing. Now, what we can do is we can provide information to our slice by using given when thens. We can describe the behavior. So, for example, there is a rule that states I cannot open an account twice for the same user. So, one user must only ever have one account. How would you do this? So, just select the slice, go to the slice editor, say given. An account was opened. When I try to open another account, then I will run into an error. The error is user cannot maintain an account, cannot maintain multiple accounts. That's our scenario here, describes the behavior. Now what we can do is we just jump here and we can provide test data. So we only provide the test data that is relevant. Let's say we have the account owner, which is Morten, who opened an account. And let's say we want to open another account for the account owner Morten. This tells us a user cannot open multiple accounts. And this is so clear that even AI understands this. So let me show you how that works. So we can just jump now to the details view where we have the AI integration, and we can just chat with our model. Can a user maintain multiple accounts? No. The system understands the rules and it works. So what we can do now is, let's say we want to showcase all the active accounts in the system on the screen. Now what we would provide is just a read model, which says active accounts. Active accounts has just a list of account owner. What we would do here is we would say we have an accounts object of type custom. So we want to have all these accounts. So the account object itself is a list, and we can edit that and say we have the account owner here and we have the account number. All right, now what we want to do is selecting this one, we want to make sure that we showcase all the fields here. So this is what our accounts will look like. Pretty nice. So we need to tell the account that it's a list of accounts. Pretty readable, isn't it? So what we now do is we can show how the account opened event contributes to our list of accounts. Let's create a screen here like this. So we have a list of accounts that we want to display, and we just copy over the field. So what we display here is basically exactly the information we received from the event model. That's good. Let's make this a slice. Now we have two slices. Of course, what we need to do is we need to describe how this read model here actually works. Now we can do this by just providing given thens. So given an account was opened, then we can describe how the active accounts read model looks like. Let's create a simple scenario here. Always start with the simplest case. Let's say I open an account owner is Martin, account number is 1, account owner is Martin. Let's ignore the initial balance for a second. So if we open an account with this information, how will the read model look like? Now, the read model will have a list of accounts. So we can provide the example here. And the account will be like account number is 1 and the account owner is Martin. Save this. Now this is what it looks like. Now we can exactly tell that if we have one account that gets opened, there is one entry in our list here and shows what information is provided. But let's say we have another use case. Let's say we can deactivate an account. What is the information we need to provide to deactivate an account? It's only the account number. So let's say we deactivate the account using the account number, and let's say it's the same screen here. So what I often do is I simply copy the screen and I link the two so I can really describe this feature in isolation. So for the system, it's the same screen, but I have a fully isolated slice. Now, what is the result of our account deactivation? It's the account deactivated event. And of course, what we need to provide is the same information, so we can just copy over the fields here and we copy over the fields here. Oh, that was wrong. No, that was what I wanted to do. So we have the account number here, and we need to provide the mapping. This is what we need to do. I need to provide the mapping here, account number, which is accounts.account number. So the system knows where the information is coming from. But the last thing we need to do is we need to tell the system how a deactivated account contributes to our active accounts read model. Now, what I typically do is you simply link them back. And what I do is here, I make this a dotted line typically, because it's just a contribution to the read model. Revalidate the read model, it will turn black again. And now I can provide another specification. And for this use case, for example, we can provide a vertical specification, which is very, very readable and very well understood also by AI. Let's say given an account was opened, then I expect this read model to have one account. That's our first step. Click plus, now the first step is recorded. Go to the second step, given the same account was deactivated, then I expect the list to be empty. Pretty nice. Now, what happens if I create this scenario here? You will see the vertical scenario format here. Let's move this a little bit further down like this. And now we can provide the same information. I can just copy the information from the earlier example here. Like this. So given the account was opened, I expect the very same information we have here. So given the account was opened, I expect one entry in the list. But given the same account was deactivated, so the account 1, I expect, this needs to be a list. Let's change that. This needs to be a list of accounts. We can say we expect an empty list. All right, pretty nice. No, that's actually not true. What we do is we expect an empty list here. This is what we expect. So we have the account opened, active accounts, account gets deactivated, account list is empty again. So that was wrong. This is not a list. That's a single active accounts model. All right, I think that's clear. And I hope that makes sense. So we can provide this information in the specifications. And the great thing now is we can again go, we just need to make sure we give it proper names with deactivated accounts, for example. And if we go to the AI, you will see what happens if we deactivate an account. It should tell us So the account deactivated event, blah, blah, blah. Consequently, this affects the active accounts. Read model updates it. So this read model only has the active accounts. So the AI fully understands how the model works and how, by reading the specifications, uh, there is full understanding how this model works. And now we can go to the implementation. Isn't that nice? I love that.